my screen okay? And can you guys hear me okay? Or am I a robot? Okay, cool. Excellent. So just a quick recap on scriptable objects. They have many uses, and the use that I showed you before was for game data. So we modeled playing cards using scriptable objects. The cards themselves, I only did a few, but like the 2 of diamonds, 3 diamonds, 4 diamonds. So each one of these objects represents what a card is. So the suit, the rank, and the picture. So this might look like a struct or a class, and you are correct. It is a class. So it's just data. And what was interesting about these scriptable objects is that we used this pattern here. So we made the field itself private so that it couldn't be changed, and then we serialized it, which is just fancy Unity talk. Oh, I broke something just now. Which is fancy Unity talk for make it visible in the inspector. There's a little bit more to it than that, but if you have something that's private serialized field, that means you will see it in the inspector and nothing else can touch it. In addition to that, we also added a public getter. So this, just to recap, if we did get rank, these 2 things are identical. This is just this is a C# convention to make a function that looks like a variable because it's nicer code. And this is maybe your C++ convention where you use the word get in a function and does that. So these 2 things mean exactly the same thing, but in C# you'll see this very often. So we used this pattern to handle our game data. So when you're playing a card game, there's never a situation where the 2 of clubs becomes anything else. If your 2 of clubs changes, usually you will discard that card and draw another card that represents it. But there's never a situation where the value of these cards actually change. So that's why we used this pattern with the private and serialized field. So today we're gonna do something completely contrary to all of that, because scriptables are amazing and they're very flexible. And I'll show you some really cool things that frankly blew my mind when I learned them, and I will show them to you now. So to show a use case, I'm going to make a UI element really quick. Oops, I don't have TextMesh Pro installed, so I'm just going to use regular text, but I highly recommend that you always use the TextMesh Pro variants of these. So what I want to model is just a UI element that displays a value. So here's my canvas, here's my text, and I'm just going to call this, I'm just going to make a quick little life text. So this is life. Yeah. So say the player has some lives, and they're going to display this to the player. So I'm just kind of making this really quick, but it will all make sense in a second. So this is going to be lives value. Okay. Let's get rid of all these cards. And I just want my text. Let's make him giant. 2 giant. No, they like break when I make them big. All right, how hard is it to import TextMesh Pro? Do it. All right. Okay, that actually wasn't so bad. Okay, so let's redo this real quick. So life readout, we go UI, we go TextMesh Pro, because this one's so much better. Look how beautiful that looks. It's crisp. I'll harp on this all day, every day. But look how ugly this looks. The built-in Unity text sucks. It's like smooth, or it's like janky and pixelated, and if you zoom in or zoom out, it changes the way it looks. All day, every day. There's no cost to TextMesh Pro. Use TextMesh Pro. It's amazing. So public service announcement aside, let me just remake what I was making there. So we got the label, and then we have the actual value. So this is the value text. So this is going to be the number 99. This is going to be the word that says lives. And then we're going to move this over here. Now, where are they? Oh, they're white. I just can't see them. So I'm going to change the vertex color to change it to red, just so it's really easy to see. I'm going to bold it. I'm going to move this over just a little bit. Okay, so this is a really janky, really thrown together life counter, but I want to show why this is such a big deal, or why it's a good idea to orchestrate your code with scriptable objects. So if you have a class that has life, so I'm going to make this really fast, and we're just going to call this the player. I'm going to create a new script, and it's just going to be called player. So this is the thing that's going to drive our life counter. So if you don't use scriptable objects, here's what you'll do. You'll start using TMP so that you can use TextMesh Pro. So you'll create a public that has life. So I'm going to make this. No, yeah, UGY TextMesh Pro. There we go. Lives text. And then we're just going to have this. It says die. Every time you die, we're going to subtract a life. So public integer lives. We're going to set this to 5. So you're going to start with 5 lives, and every time you die, or no, we're going to say update lives, like this. Okay, so when the game starts, we need to sync it. So we say update lives with our lives. And then every time we die, here's what I'll do this. So public void die, we subtract a life, and we update lives. Okay. One more thing I'm going to add. No, actually, that'll be this will work. This will work. No, one more thing I'm going to add. This is an attribute, so I'm going to be using the square brackets, which means an attribute, and we're going to use context menu lose life. So because I need a way to call this function in like while the game is running, but I don't want to write code that kills the player. So the context menu means when I right click on the player script, I now have this button that says lose life. And so when I click that, it calls this function. So that's just really handy. So now we have to add that. Let's call this the player. We'll run it. And so when the game starts, we'll see the lives change to 5. And every time we kill the player, life goes down. Okay, so this is very standard. You've probably written code this way before. But I ask you, what happens if there's no UI in your game, right? What happens if you just want to test the player and have no UI elements? How do we get rid of this? So just say null, yeah. So if I'm like, no, I'm just testing the game. I just want to test to make sure the player can start. Oh, null reference exception. Oh, I have to set the lives code. So now I have to bring in my UI and I have to link it. So not a big deal for small games, but for big games, that kind of sucks. If you just want to test Mario running around a level, you have to have the UI in your game. And so if you're trying to debug something, naturally you want to make your environment as small as possible so you can narrow down where the issue's coming from. And if you have to include your UI anytime your player moves, that sucks. So we call that tight coupling in programming, is that our player is tightly coupled to the UI. So we're going to use scriptable objects to get rid of that. So what we're going to do is create a new scriptable object, or a new script. This is just going to be called an int variable. Actually, before I get there, I want to show you one more thing to help you to kind of show you where we're going with this. So maybe you've seen a Unity event before. If we do a UI button, Texture Mesh Pro, obviously, I'm going to call this the kill button. And there it is in the world, just in the center of the world. And if you've ever used a button before, you scroll down your button and you've got this on click, and it's this funny field, and you hit the plus, and this field is called a Unity event. So what I can do is I can drag the player into this field, and I can select the player function, and I can select die. So that's pretty cool. So what's happening here is I am rigging the death function to the UI function. So this is just for testing. This probably, or I don't know, it depends on your game. But what's cool is every time I click this button, it kills the player. It subtracts 1 from the lives and updates it. That's pretty cool. So this will replace. I don't need to use this context menu anymore because now I have this cheat button to kill the player. But what's really cool is how flexible this is I can say, you know what, I also want to kill the player. But when the player dies, I also want to turn the UI off. So check this out. I can just say, so on the same Unity event, I call a function that has no arguments. I also call a different function that has an argument. In this case, it's a Boolean, and I set it to false. So now I click the button, it kills the player, and it also turns off the UI. So events are very powerful. One, they're flexible in that they can do all kinds of things, and two is, well, they're very flexible. So I want to make use of this event system in other places. So yes, so that's what we're going to do. So I created something called an int variable, and I'll show you what it is. It is very basic. It's going to be a scriptable object. And anytime you make a scriptable object, if you need to create it, you have to write yes. Yeah, perfect. Actually, that's amazing. So I'm using something called GitHub Copilot, and I just got to gush for a second. GitHub Copilot is amazing. It's an AI pair programmer, and it wrote this whole thing for me. I didn't write that. That was super cool. So int variables, right? So we don't need the start and update because this is a scriptable object. Scriptable objects don't have start and update. Wow, that's really cool. I'm gonna write it. I'm gonna write it myself. So the first thing we need is, first thing we need is a serialized field. Say private int. This is called. It's gonna be super boring. It's just gonna be called value, and then value with an uppercase. We're gonna say get, and then we're gonna say set. I'm gonna come back to that in a second. Public void. Yeah, there we go. Set. Okay, so there's a lot going on right now. So what we're doing is we are wrapping. We're not M&M. It's wrapping with a W. So we have an integer. That's our base. Our base value is an integer, and that's what the player's life is. The player's life is an integer. So we're wrapping it in a class, and classes are reference values. So we'll be able to reference this value from many places in code. Now, value is hidden. It's private. so that no one can touch it. It's serialized so that I can see it in the inspector, because that's really helpful. The inspector is this thing over here. When I touch something, I am inspecting it, and these are all the values in the inspector. So now what I want to do is I need to be using what do we call it? Unity engine dot events, because I want a Unity event. So we're going to do private Unity event. Let's type integer. Yes. On value changed. Actually, that's super cool. Yes. So over here, this is a Unity event, but I'm gonna. So there's two kinds. This is called a generic class, or if you're used to C++, it's called a templated class. Yes. On value changed. Changed event on value changed. On int value changed. Okay, so why are these different? So Unity event, traditionally, it takes a function that has no parameters. So in the case of this top one, player die, a player died is just it's a void returning function that takes no arguments. So I'm going to use the word signature when I describe functions. This line is its signature. It has an access modifier, it has a return type, it has an identifier, and then it has an argument list. So signature just refers to what it looks like. So this function signature is a public void, and it has an int argument. So we're going to use both of these. I'll come back. I'll explain more about Unity events, but does anybody have a question up until this point? I want to make sure that I didn't lose anybody. So any questions so far? All right, it's cool. If you guys do have questions, please stop me and interrupt me. I'm going to keep explaining this stuff because it'll get a little confusing, but please let me know. So what we want to do is when the values changed. So here's what's up. In this example with the UI, the event is I click a button, and the response is update this UI element. This is very hard coded, this player code. When the player dies, update the lives. So if we ever want to add functionality to this, we have to literally type it. That's okay, but it's not flexible. And I really want flexibility here. So in this sense, we're making something very generic, because this int variable can be used for all kinds of things. It could be used for money, it could be used for lives, it could be used for levels, just all kinds of things. But really what I want to do is I want to raise an event, or I want to respond. In this case, I respond by updating the lives, which is a UI element. In this case, we're going to do something generic. So we're going to alert void raise, and also raise with an int. These private or public? I'm gonna make them private for now. Yes, they are private. Okay, so raise and raise, these are private because these don't exist outside the class. Now this one is going to do two things. Actually, we're going to use the word invoke because that's what Unity uses. It uses the word invoke. So when you, I'll just keep writing, and then it'll make a little bit more sense once I write it. Okay. So I'm kind of doing this two things at once here. Um, so so invoke will get called when the value changes. So whenever you change the value, it will tell this event to call every function that's in its list. So to the same extent that when I push the button, I'm invoking the Unity event. And to invoke an event means go through every item in your list and call that function. So first it calls die, and then it calls setActive. So it's going to do the same thing. Whenever we set the value, we set the value, and then we will invoke our event list. So we'll go through every single one of the untyped. This one is untyped. This one is typed because it has the word integer here. This one's untyped because it's just a function. So first we call the untyped, and then we call the typed. I guess this is a little like extra. I guess I can just get rid of that. I'll come back to this. Yeah, that works. Yeah, that's perfect. Okay, so we're going to do two things at once. So we're going to let everybody know, one, that the value has changed, and two, value has changed, and this is the new value. So we give it the new value. That's a bug. We should use value. Okay. So we're not quite done yet. We're going to do one more thing. This one I'm going to bang out. This is going to be a int game event listener. Okay, let me just crank this guy out real quick. So this one is also going to be using engine.events. No, bad copilot. Yes. Okay, so it's going to have serialized. No, it can be public. Public. It's going to be called an int game event. Game event. And then we're going to say public Unity event response. It needs both. Okay. What's cool is that there's no update function. You got to get rid of that. That's always nice. Anytime you can get rid of update, pat yourself on the back because that's a big deal. Instead, we're going to do private void look, I guess. What better word for this? All right, so add listener when the listener changes. Now we call it response. Okay, bear with me for a second. Okay, so we do response invoke, and we'll do response invoke with typed response. Okay, this will all become clear in a moment of what's happening. When the game starts, we take this game event, this int game, no, it's called int, oops, it's called int variable, that's what it is. And we're going to, I guess I do need to make these public. All right. But I don't want to see them in the inspector, so I'm going to use hide in inspector. So this part just means don't show when selected. Because everything's going to be run through code, so the developer doesn't have to change anything. So on value changed event. We're going to add a listener. and it's called response, and then int variable dot on value changed on when the int value is changed, we're also going to add a listener, and it's going to be the response as well. Does that make sense? This one is no, okay. Response. This will be typed response, just to be sure that it's doing what I think it's doing. Okay, so a listener. So events. Think of a bell. When a bell rings, so like you go to junior high school and the bell rings and you know to go to your next class. So the bell ringing is the event. And on the first day of class, you were told, hey, when the bell rings, you need to do something. So that is adding a listener. Is once you graduate, then you don't care if the bell rings, you do nothing. So you're no longer listening to the event. Right now we're saying when the event gets invoked, we want to respond by calling this function. And then these functions call other events, but I'll show you why it's kind of recursive, where events just call other events. But it's because we're going to make full use of Unity's drag and drop in the editor and stuff. Okay, so this is pretty dry code. It just kind of forwards its stuff, but I'll show you what's up. Okay, so the player is going to change a little bit. Instead of the player being tightly coupled to the UI, where we're directly using UI code, we're not going to do that. Instead of using this int lives, we're going to use int variable. And then we can't directly set lives, so we're going to do lives.value minus equals 1. And then lives.value. Lives.value. So this dot value that we're using, how do I split you? There we go. Okay. So we have to set the value. The int variable itself is a class. The value is the actual integer amount here. But notice that it still looks like a variable, right? It's not a function. It looks like a variable, but it is a function. So when we change this by subtracting 1, we get rid of this altogether. Yes, this is perfect. We don't need update also. And there is no start, actually. Yeah, check that out. We got rid of 2 functions. The only thing that the player does is what it should do. When you die, lose a life. That's all it does. It doesn't care what else happens. Just when I die, I lose a life. Secretly, when the value gets deprecated here, when the value gets set, it calls this set value function with the new value, and it invokes. So whenever you change the value of this int variable, it calls its events. That's pretty cool. So the player has now been decoupled from UI code. All it has to worry about is subtracting its life. That's all it cares about. It doesn't care about UI or anything else, any other repercussions. Just subtract my life. Now, this game listener, we're going to change it up a little bit because I got a little ahead of myself and it's too soon to be totally generic. What do we got here? Get mystically clear value. Get value is equal to value. Okay, it's a little funky. Value with no score in front of it. This is a keyword. I'm surprised my IntelliSense isn't highlighting this, but this is a keyword. This should be blue. Wait, well that's why. Actually, no. This is. Oops, that's wrong. There we go. Yes. Okay, it's a getter. A getter just gets the value. So this arrow just means I'm a function, and it just returns value. Yes, that makes sense. That's get. And set without the leading underscore. This is a keyword. This means it's this thing here. So when you set the value, it's a function. Yeah, it's a little weird, but I like this because it just looks nicer. Because when you're implementing the code, you just use value. You don't use any functions. So this is a little bit of black magic to get my functions to look like variables. So it just passes that in there. So what else we got here? Serialized cannot be found. Serialized field. What else we got? Cannot convert an integer to an int variable. Right. Well, that doesn't work anymore because this is a class. What else we got? Cannot create an instance of the abstract class. Okay. I see. All right. So Unity, in newer versions of Unity, they fixed this problem, but in our case, they didn't. So this part's a little funky. Oops. But so Unity, in later versions of Unity, this is fixed. I'm using 2019, so this is a slightly older version. So we have to implement this a little bit. We have to implement this manually. I'm just going to do it right here. So public Unity, or this is called a class. It's an int Unity event, and it's a Unity event of type int. That's it. And it is system.serializable. Okay. Okay, so in order to get Unity to accept the generic, we have to actually declare it. So I've created a class that inherits from Unity event that accepts a type integer, and all it has to do is exist. Because it's this is really funky. This only really happens in Unity because of serialization. Unity has to know what it is before it can draw it in the inspector. So we tell it what an int Unity event is ahead of time. It's just this, and then we use this instead. So that's a little funky, but it gets rid of this error, and it means we can see it in the inspector. So let's make another data. We're going to call this variables int variable. So because in the int variable, I have this line of code up here, this create asset menu attribute. It's an attribute because it's in square brackets. The create asset menu is the right click menu, and this is the menu it's in. So in order to create a scriptable object, you have to create it in the project. So this is going to be called players lives. Now we go to player and we drag that in here. Boom. So now there's no situation where the player is ever incomplete, right? So before, if there was no UI, that would cause a problem. But here, if there's no UI, it doesn't matter because the player is complete. We just assign this value, and it's all good to go. Now the converse of this is that we need this listener. I'm going to change this up a little bit because I was trying to make it really generic and something that would be used for everything. And I can show you that, but we're running out of time, so I'm just going to I'm going to rename this. This is no longer an int game listener. This is an int UI readout. Okay, so we're going to get rid of these, and we're going to say update UI. Private void, not public void updates UI. Yeah, so we don't need this. And then you changed update the UI. Okay, so when the game starts, sync the UI with the value, and then we're going to add the listener, update UI, and then this time we're going to couple this thing. So you've got the source, public, what is this going to be? Or text mesh pro UI. Perfect. integer readout. All right. Sorry, I'm double backing a little bit because we're running out of time, and I don't want to hold you too long. So I'll have to fix this right now, actually. A quirk of Unity is that the name of the class must match the name of the file. So that's what I'm doing now. Is I'm just changing. This is an int UI readout. Okay, so generic is out. Tightly. This thing is going to be, tightly coupled, but I'll show you why. So integer readout dot text is equal to variable text dot value dot toString. Close. You got to be capitalized. Okay. So the short version of what this is doing is when the game starts, it will subscribe to the event. So it takes the int variable and says, whenever you change, I want you to call this function update UI. And all I do is I take the current value of the integer from that the value and I stick it into the text. I convert it to a string and then I stick it into the text. Okay, so sorry, I hope that I got a little ahead of myself. So we'll just do this instead. So the life readout is going to have the int UI readout. Here's the int variable over here, the lives, and then here's the value text. Save it and run it and check this out. It's off. Where is it? Value text. Where did you go? There it is. Value text. You disappear when you start? No. Oh. Weird. Whatever. Okay. So I start the game and it syncs the lives. Stack Overflow. Whoops. Oh dear. Let me fix that real quick. Oh, yes. Aha. That's bad. Okay, so Stack Overflow happens when you repeatedly call functions over and over and over again, and this causes Stack Overflow because you sign it to the value. When you sign it to the value, it sets the value. So it sets the value, but then you sign it, and then you sign it. And that's bad, Rich. So we're going to do underscore value is equal to this value. So we set our inside value to the new value, and then we invoke this function, and that will. And now you know where the internet help site gets its name from, Stack Overflow. Okay, that's gone. And that disappears because I still have this kill button. Let's get rid of these. Whoops, no. Okay, so first to start off, what I want to do is this player lives. I want the value to start at 5. So I set this value in the inspector, save it. Then when the life readout happens, it sets the current value to 5. And then when I click the button, the only function on this kill button is to have the player die, and there it reduces the value. So here's what's up. Here's why I like this. If I disable the UI, there's no more UI. Well, I guess if I disable, I need the UI so I can click on the button. If I disable the life readout, so in this scenario, there's no UI. I took it all out. I just have my player in there, and I kill the player. And sure, the value, well, you can see here the value does change because I mashed it a whole bunch, but there's no error. There's no missing reference. Your UI is not in the game. That can get out of hand. Like if you have enemies, you've got enemy managers. You know, the enemy manager's not in the game, or and then it can get out of hand. So the point is, this is modular. The player doesn't change. The player is super simple. Instead of the regular integer, it just has it keeps its value inside an int value, and it just behaves like normal. No UI code, nothing else. Then the UI readout has no concept of a player. It has no concept of what it is that it's showing. It doesn't know if it's showing money. It doesn't know if it's showing player lives. It shows an integer. and that's the code to do it. So I'm going to change it up. I know time's running out, but I'm going to do one more quick to show some more power. I'm making a formatted int UI readout, right? So, oops, go back. So I'm just going to throw this guy together. Oops, nope, that's the wrong thing. Int readout. Wait, come back here. Formatted in. Yep, formatted. You're the same code, except you're called formatted. And this time I say the player, well, no, prefix plus. And here I'll say okay, so let's put that on board. Let's duplicate this. And instead of having the int readout, it's going to be the formatted int readout. Uses another one of these. Use this one, and then this one has a prefix. If we show this, get out of here. What? Get back here. Why show up? Weird. I wonder what's going on there. I have like something hidden here. Oh well, doesn't matter. The point is, on this one I have an int readout. On this one I have a formatted int readout. When I start the game, they're going to look different. I don't know why they're jumping around like that. It's kind of funky. But the point is, now I have two different readouts, right? No change to the player code. Player code is exactly the same. I just have one class that shows an integer just by itself, and I have another class that has a prefix. And so if I want to change how the lives are read, like I use a different class. So my point is that no longer is the player's code coupled to the UI. I can decide which they all source the same value, and then I just have a class that decides how it gets drawn. So I guess I don't need this label text at all. I can delete you altogether and play that. And then yeah, I don't know why it's weird. No, it's not doing that. Whatever. So yes, modularity. In order to change the way that the code or that the integer is read, I just change the class. No changes to code. I have to write code for every every way it gets formatted. But once I write this prefix, then once I write a suffix, then I've got everything that I need. Or like I've got a whole kind I've got many different ways to show off this integer without changing the player code at all. Player code is super simple. And it is now loosely coupled to the UI because the UI doesn't know anything about the player and the player doesn't know anything about the UI. They have this middleman, this cohort called the int variable, and you can do things like just based on that integer. And now your code is modular and you will have less bugs, and also it's really cool and powerful. Any questions on that? I know that was a lot. Okay, no worries. So this was a very bare bones example, but I highly recommend Unity Scriptable Object Architecture. If you were fascinated by this, if this really interested you, and you want to know more, I highly recommend checking out this Firefly video. This Austin Unite is a convention for people to talk about Unity, and this guy takes these principles and dials it up to 10, and it's so cool. And I would love to talk to you about it if you're interested. But that's another day. So You get all kinds of fancy stuff with this. So I apologize. I admit I did not plan this ahead of time. I kind of did this off the cuff. So I admit that I probably confused you a little bit by doing that whole extra Unity event thing, but turns out you don't need those anyways. So the short story is subscribe an event to a listener handles the code, and now everything is super small and it's modular and it's beautiful. And do you guys have any other questions? If you don't, I'm just gonna keep going because I got to gush. There's this really cool function called onValidate. Invoke. So when the game is running, I'm not sure if this will work, but I'm gonna try it out. Game is running. I've got these things. Let's put this up. Go back here. Player lives. If I set this to 100. Yeah, check that out. Sorry, I just got to gush for a little bit. But this onValidate gets called in the inspector every time you make a change to the inspector, it calls it. So now I'm not even messing with the player. Like I'm not even touching the player at all. I'm touching player's doing his thing. I'm just touching this value. And look at that. It's updating in the UI in real time. Right? Like what? That's so cool. Come on, that saves you so much time. So this totally decouples the player from the UI because now I don't even need the player in the game at all to test my UI. Look at this superpower, right? No player. I got a scene just for my UI developer, and all he does is test to make sure his UI works and responds. And I got a different scene just for the player, and they don't ever talk to each other. All they need to do is go through this variable. How cool is that? It's modular. You can edit it in the inspector and it'll update in real time. I'm sorry, but like, yeah, that's so cool.
Rich, if I may interject,
Yes, please.
one thing that's cool there is because of the scriptable object, correct me if I'm wrong, but scriptables, you make a change even at runtime and it retains the value. So unlike traditional, when you're running your game and then you save a value by, say, right-click, copy values, stop play, right-click and paste the values in, because you're running off of a scriptable, you can actually change that value at runtime. Notice it's already at, 184, 164 there, whatever you stopped at. So the UI in the scene is not updated because the game's not running, but that value is updated and remains updated. So as he's playing, there you go, 184. You can change it at runtime, and then it stays. So that's just a quicker, faster way to say I'm making a change, and this is what I want it to be. Good. You don't have to worry about running at runtime or not. It's saving that value, and you just continue on with your work. Now, I've mentioned before that I have a client that would do escape rooms. We have an entire system built Unity events and scriptable objects, and everything just calls everything. And it's so wonderful because you can get to the point where you can just say, you know what, this thing happened. And with the events and with the listeners, it calls off the UI to make a change. It calls off the audio manager to play the sound. It calls off a particle system. All that stuff, that daisy chain of events happens from one little thing changing. So if you build your system right, so much can happen from one tiny little, you just throw that first domino and then just watch the rest fall, and it's awesome.
Yes. Thanks, Matt. Also, thanks for coming, man. I didn't see you pop in. Thanks for being here. But yeah, so I went a little bit over. If you guys got to bounce, thank you for coming, and I totally understand if you got to bounce. But yes, scriptable objects are amazing. I use a very similar architecture to the one that Matt uses in the escape room games in all of the gambling games that I make for the UNLV studio. They're all engineered with or architected with scriptable objects, and it's so easy to just throw stuff together. You don't have to have stuff talk to each other, and because it's modular, I can copy and paste all these things into a brand new game. And if I change the player, I don't change the way that integers are displayed to the screen. So fast iteration and flexibility is key. Does any Does anybody have anything they'd like to add or comment on?
It's pretty
That's cool.
straightforward.
Yeah,
I mean, I'll have to say that thanks for this tutorial, man. This actually looks like it's really cool. I'm probably gonna use something like this in the game I'm making right now.
that's cool. You work
Yeah,
in a Godot, don't you? Primarily.
yeah, I used to Godot, but actually figured out a way I could do something similar to this
Hmm.
in Godot.
Oh,
I
cool.
could make yeah. They use
I
something called resources. It's pretty much the same as
gotcha.
scriptable objects. You can
Cool.
hold
Yeah,
data, stuff like
that's good
that.
to know. I always wondered how other engines handled the same thing. Because as far as I know,
Yeah.
literal scriptable objects are unique to Unity, but I'm sure other engines have the same problem where they need data that can be read and written to and stuff. So yeah, feel free to stay and hang out, and I'll just keep talking about Unity if you guys want. But that this is an acceptable point to end the meeting. Thank you guys for coming. Thanks for being a part of this. We might only have one or two meetings left. Actually, I think next week's going to be our last meeting of the semester, because then the week after that's finals, and then the week after that uh, is the start of winter break. Um, there has been some interest expressed in continuing meetings through the winter break, so we'll keep you posted on that if the time changes or anything. But we won't meet, or of course we can meet and we can all hang out during the week of finals, but we won't do any major content because a lot of people will be studying.
Gentlemen, I have to delta out. Uh, Richard, thank you so
Mhm.
much. I really appreciate it.
For sure, man.
Hopefully, I'll see you this Wednesday. I'm sorry, when's the next in person meet? Wait, there's Thanksgiving.
Yeah, the next in-person event will be the game jam, and that is pending. So keep an eye out for more information on that.
For sure, for sure. All right, gentlemen, I'll
Cool.
take my leave. Good luck, and yeah, take care of yourselves out there.
Take it easy, Keon.
You too, man.
But yes. Ben, if you're well, actually, for all you programmers, this pattern is called the observer pattern. You may have heard that in your Gang of Four programming software design patterns. This one we just talked about is the observer pattern. The cards. This is the flyweight pattern, and also possibly the memento pattern. If you felt like saving something, you could also use scriptable objects to be a memento. So we are learning stuff that's applicable in school here because these are design patterns. It's all good.
Yeah, Godot actually has a built-in implementation of the observer pattern.
Oh,
It's called
cool.
signals. Like you say in the game, right? Like you can make a character emit a signal, right? So if a character dies,
Mm-hmm.
you can just emit a signal. It doesn't matter who's listening to it. You can connect say the UI to that signal.
Oh, that's cool. Are
Or if
those
you don't, but if you don't, yeah,
and those are built into the engine?
yeah,
That's
signals.
so cool.
That's what it's called. Yeah.
Yeah, I've used signals before, like a package called signals, and it's not built into Unity, but it is awesome. So that's actually really cool that Godot supports that right out of the box. But yeah, so anytime you work with events, everybody has their own terminology. So I think I caught you here, or you say emit. Emit is probably the same thing as invoke or raise. There's just different words to say trigger the event, but they all mean the same thing. to that point, if you are ever inclined to use signals in Unity, I guess I'll just link that to you right now. There signals. Dang. Yeah, I'll pass this along to you. Just if you're interested, Adrian. It's like a few hundred lines of code, but it's a basically global events that you can access from anywhere. And so you get a signal, and then in this case you dispatch the signal, but dispatch just means emit. It's the same thing. But
Yeah, I've been wanting to try to get more into Unity, but just haven't had that much time.
it's all good, man. And at the end of the day, like use what you're best at, and you seem to have a pretty good handle on Godot.
And about like the only thing I'm worried about is that if you want to get a job right in the game dev industry,
Oh
there are
yeah,
not many people out there looking for Godot.
this is true.
Yeah, that's why I'm at least trying to learn both. That way, if like say I needed if I'm getting a job and they need Unity, I could do that, or if do something else for Godot, I could do that too.
Yeah, that's cool.
Speaking of the design patterns and such, I recently had a job interview with Unity for a senior position. I didn't make it, so I have a lot more to study apparently. But I am now learning more about getters and setters, and I recently learned that when you have a variable, any kind of variable, public int, my int, secretly under the hood there's a get set command that comes along with that, which says you can get the value or you can set the values. You can say, what is this value, or I want to set this value to a number. Well, you can actually explicitly define the get set for any variable, and then inside of that get set, you can actually put another method. So an example would be, say you're making a weather system, like a weather, information, and part of it is the temperature. So if your system is built in, say, Celsius, but then I, as a user, have my settings set to Fahrenheit, part of my get command can be get the temperature, but then I send it my parameters, and the get command for that temperature value will actually run a method that says, hey, based upon the user settings, modify this value before you send it back. So you don't have to give them the exact data they're looking for. You can actually give them a modified or an altered version of what they're asking for. So if you think of like a spies, right? If you ask for information, you might not be given the full truth. You might be given, some information. So you can actually modify that response before it's sent back. So I have a little sample that I built for myself. I was learning about this. So similar to the lives that Rich was showing, I had a score system, and just you pick up a coin, it adds one to the score or removes one from the score, that kind of thing. So I have a public function or public method that says modify score, and it has a set get to it, and the only thing it has is a set. There is no get, because you never get the score from the coin's perspective. You just set the score. You just say, I am a coin, I've now been picked up, player collided with me, therefore they got me. So now it goes and tells the score manager, hey, call your set command for this, and here's my value. And then that value is evaluated to say, hey, would this value put us either above or below the minimum or maximum? Then let's truncate that. If not, just go ahead and add to the score either a positive or a negative value. So I have the flexibility to say it's a positive value. I picked up a coin, and every coin has a public field that I could change. I could say 1, 5, 10, 50, 10 million, whatever. Or I could say a negative one. So I could actually make either like a bad coin, or it could be maybe a trap or something that if you touch it, it takes score from you. And that same function, that same method there for modify value can be used for, say, you buy a power up, right? It can call that same thing and say, modify the score by -50 because you're buying this power up. So the flexibility there is incredible.
Yeah. Yeah, if part of the scriptable object architecture is that So more features that you could add to this int variable would be like a max value and a min value. And so then you could say when you set it, clamp it to the min and the max, which is pretty cool. So you can bake like limits into your values natively instead of like every single place, which I don't know. It's really cool. Please check out the Firefly video, the scriptable object architecture video, because it really opens up modularity and flexibility. And also teaches you a little bit about inheritance. Cool, guys. Well, I think this is a good place to cut it. Thanks for coming. And I will see you next week for the asset shuffle. Thank you, Ben.
Yeah, thanks for the story, man.
Yeah, thanks for the talk.
For
It's
sure, man.
very insightful.
Thanks. Thanks for coming, guys.
All right, see ya.
Have a good rest of your evening. Later.